floating through the clouds of Jupiter, gathering in the organic matter which may be there, with eyes much too big to be reasonable. And you can see they go like a ramjet, sucking in the atmosphere at the front and blowing it out the back. And if I had that hydrogen balloon, wait, I have another one. If I could only make a hole in it without bursting it. The organisms on Jupiter, if any, probably do better than that. We do not know that there's life on Jupiter. I don't want you to think that it's something that is considered likely. We do not, on the other hand, know that there isn't. It is an interesting, exciting possibility which we will have the opportunity to explore in future spacecraft exploration of Jupiter. By the way, everything we've been talking about, which we will have the opportunity to explore in future spacecraft exploration of Jupiter. By the way, everything we've been talking about so far about Jupiter is in an extremely thin layer in the very top of the atmosphere of Jupiter. Thank you. It's this green layer right here. In fact, it's thinner than we were able to paint it. It is the atmosphere and clouds that we've been talking about. Below that, this pinkish region in this model, is liquid hydrogen. And below that is solid metallic hydrogen, a sort of hydrogen you don't bump into every day on the Earth. Hydrogen as a metal is not a commonplace on the Earth, and the reason is that the pressures here are simply not great enough to make hydrogen into a metal. Because Jupiter is so massive, it's the most massive planet in the solar system, hydrogen does get made into a metal there. Possibly in the very heart of Jupiter, there is a core of rock and metal, a planet something like the Earth, hiding in the inside of this enormous hydrogen-rich liquid and gaseous planet. Now, let us examine briefly a few more things in the Jupiter vicinity and further out. Here is simply a reminder that spacecraft are on their way to Jupiter and beyond to take close-up looks, much better than any which has been obtained so far. Here are 4 drawings made by visual observers on the Earth of what they think they may have seen on the surfaces of the 4 big moons of Jupiter. And here are 4 maps of the 4 moons. And you can see here is Io, the innermost moon, Europa, the next one, Ganymede, third one, and Callisto, the 4th one. And there are features on the surface. But what do those features mean? We haven't the foggiest idea. We know that they're icy. Here is an astonishing picture of Io, taken in the spectral line given off by sodium. And it turns out that Io has left behind it a cloud of sodium gas, swept away from its surface. And what some people think is that Io once had oceans in which were sodium salts and potassium salts and other such salts. The water escaped to space just as the hydrogen escapes from the Earth, leaving behind the salts which are now being blasted off by a high radiation environment which surrounds Jupiter. That is one of many indications that the moons in the outer solar system are not like our moon, are very different sorts of places. Now, beyond the Jupiter system are many other objects. Interior to the Jupiter system are many other objects also, because between the orbits of Mars and Jupiter are an enormous array of asteroids, little rocky objects, but they're not all rocky. This is an artist's conception of one, but many of these objects now turn out to be rich in organic matter, since they probably were formed in the earliest history of the solar system. That suggests that organic matter was very abundant early at the time that planets were being formed, and the 2 moons of Mars, of which we'll talk about in a later lecture, now seem to be made of organic molecules. If we move outwards from the asteroids and Jupiter, we come to this object, which may not look familiar to you, This is in fact Saturn, but seen with the rings edge on, so you can't see them. And maybe you can see a little hint of color in the region just above and beneath the shadow of the ring. If we look at Saturn at another time, we see much more color, and whatever it is that colors Jupiter is probably part of the coloration of Saturn as well. Here is a lovely picture of Saturn as seen from the surface of one of its moons. Notice the presence of some kind of ice, maybe water, but maybe ammonia, maybe methane, on the surface of the moon. And notice the shadow of Saturn on its rings, and also note the break in the rings, so-called Cassini division, which seems to be a place where ring particles aren't. What are the rings of Saturn? Well, I'll mention it in just a moment. Here you can see the rings edge on from the surface of a moon about halfway out, and you can see 3 interior moons in this artist's drawing in the ring plane. Were we to go very close to the rings, we would see that they are a swarm of orbiting snowballs. There are millions of snowballs in orbit around Saturn. It would be a great place for a snowball fight. It would also be a very interesting place to examine close up. The rings are either a place where a moon was torn apart by the gravity of Saturn, or where a moon was prevented from being formed by the gravity of Saturn. In addition, there is an amazing moon of Saturn called Titan. It is a moon with an atmosphere. The atmosphere is made of methane and hydrogen. It is hotter than it ought to be on the surface. It seems to have a cloud layer which is brown and unbroken and possibly made of organic matter. It is an astonishing place, and it probably really looks more like this picture where we can see the brown clouds, and the artist has drawn a kind of methane volcano erupting. The outer solar system is the object of many space vehicle missions now underway. And I'd like to close by saying a few words about those space vehicle missions. 2 of them have already been launched long ago, Pioneers 10 and 11. Pioneer 10 has already passed by Jupiter and will leave the solar system. Pioneer 11 has passed by Jupiter, but in 1979 will enter the Saturn system, and if it still survives, maybe we'll get some pictures and other data in a preliminary way of what Saturn is about. Voyager, which I talked about in the last lecture, is a splendid, magnificent kind of spacecraft. You see booms for magnetometers and atomic batteries, an enormous antenna to send information back to Earth, and over here, a set of instruments to examine very carefully Jupiter and Saturn and their 20-odd moons, the rings of Saturn, Uranus, if we're lucky, and the newly discovered rings of Uranus. This will be an astonishing set of results. It will fly by the Jupiter system in 1979, the Saturn system in 1981, and therefore in just the next few years we will see coming through 50,000 photographs, an enormous number of spectra telling us about composition and pressure and temperature. We will really learn what these places are like. And then beyond that, there is one last approved mission by NASA in which a spacecraft called Jupiter Orbiter with probe will go into orbit around Jupiter and then drop a probe into the atmosphere of Jupiter, so that for the first time we will examine close up the chemistry, pressure, and temperature of a Jovian planet. The Jovian planets, hydrogen-rich, like the primitive atmosphere of the Earth, are very different from the terrestrial Earth-like planets. It may be that we can learn about the early chemistry of life best by examining the outer solar system. Perhaps even there is life out there. What is guaranteed is that those worlds are entrancing, fascinating, and well worth a deep analysis. In only a few years, we will have made such a deep analysis.